In this lesson, we're going to learn about mid-segments of triangles. The objective is to use properties of mid-segments to solve problems. So let's look at the definition of a mid-segment. A mid-segment of a triangle is a segment connecting the midpoints of two sides of a triangle. So let's look at this triangle below. Here the two midpoints are, we have point D and point E are both midpoints of two sides of a triangle. So the segment DE is the midsegment of that triangle because it's connecting two midpoints of two sides of a triangle. Now the midsegment theorem tells us that if a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side, the side that is not connecting the midpoints to, and it is going to be half as long as that third side. So in this particular diagram, we have DE is parallel to AB, and DE is going to be half the length of AB, or you could say that 2 times DE, the length of DE, is equal to the length of AB. However is easiest for you to set up the problems. You can use either version of that. So let's look at a few problems over on the right. In problem 1, it wants you to identify the 3 pairs of parallel segments in triangle DEF. So looking at the congruence markings on the sides, you can see that point M is the midpoint of DF. Side DF, point M is the midpoint of that. So its midsegment, the midsegment that is parallel to that one, is going to be ON. So we have DF parallel to ON. So let's look at a different set. Let's look at the side FE. From the congruence markings again on that side, we can see that point N is the midpoint of that side. So the midsegment that's going to be parallel to this side is MO. So we can see here that FE is parallel to MO. And then finally, the third side is DE, and from the congruence markings on that side, we can see that O is the midpoint of that side. So the midsegment that it's parallel to is MN. So DE parallel to MN. So those are the 3 pairs of parallel segments in triangle DEF. So let's go into problem 2 and look at finding segment lengths. In problem 2, we have triangle RST, and in this triangle it tells us that points G, H, and K are midpoints. It also tells us that the length of RS is 28, and it tells us that the length of GH is 20, and it tells us that RH is 22. So now it wants the length of KH, ST, and GK. So let's look at KH. KH is going to be the mid-segment that's parallel to the side of the triangle that's RS. And that one is 28. So that means that KH, the mid-segment, the length of the mid-segment, is equal to half of that side RS that it's parallel to. So that's half of 28. So its length is 14. So now let's look at ST. ST is the side that is parallel to mid-segment GH. So that means that GH is half of ST. Because GH is the mid-segment that's parallel to ST. So GH is 20. That's half of ST. So multiply both sides by 2. And ST is 40. The last one we have to find is GK. GK is the mid-segment that's parallel to the side RT. So GK is half of RT, and half of RT is RH. So that means that GK is equal to RH. So it's equal to 22. So looking at problem 3, we're going to be using the mid-segment of a triangle. So in this problem, they want to know what is the distance across the river. They give you a couple of distances here, 55 and 55. So we know that these two are congruent segments, and that this point is a midpoint of that side. So what we're wanting to know is the distance across the river, so we'll call that X, the distance across the river. And the distance across the river, since this is a mid-segment of this triangle, is going to be half of the side that it's parallel to. So here we have X is equal to half of 92. So it's going to be 46 feet across the river.